In this example, we're going to find the angle between two lines. So, we're asked to find the acute angle between the lines x plus 2y equals 7 and 5x minus y equals 2. What we're going to do is we're going to use the slope of each line to give us vectors that point along each line, or at least are parallel to each line, so then we can find the angle between those two vectors, and hence that will be the angle between the two lines. Put the picture in here to help to figure out which one was the acute angle. Notice in this case I want this one going this way, so I want one of my vectors to point kind of off to the left here, and one to point up. Alright, so the first line here we can check has a slope of negative 1/2, right? If we move the x over to the other side and divide by 2, we get negative 1/2. The second line, well, move the 5x over and divide by negative 1, we'll get 5 for the second slope. Alright, so let's represent these as vectors. So this again is rise over run. My run here could be thought of as 2 and my rise being negative 1, or my run could be negative 2 and my rise could be 1. I just need to have them have opposite signs. Since I want the one that's pointing off to the left this way, I'll use my run being negative 2 and my rise being 1 for my vector that represents the slope for that line. Over here, I get a rise of 5 over 1. I could have positive 5 and positive 1 for my rise and my run, or I could have negative 5 and negative 1, just as long as they have the same signs. But again, I want to go up and to the right, so I want them both to be positive. So I'll use 1, 5 for that vector. And notice that my first part here is giving me my run, and my second part is my rise. Now that I have my vectors, I can use my angle between two vectors formula to find the angle that we're asked to find. Cosine of theta here is the dot product of the vectors over the product of the magnitudes. The dot product is 3. The magnitude of the first is root 5. Magnitude of the second is root 26. And this looks like a nice fun problem for a calculator. Do the inverse cosine and get approximately 74.745 degrees.